Hello everybody. Well, today we're taking on we took on another project for the last day and a half, rebuilding this YAESU FP 1030A power supply. Upgraded everything. We upgraded the 6 amp connectors here to 12 amp. These remain at 20. We added variable voltage to it. Took out that stupid cigarette lighter plug. Back here, we added twin 50 amp plugs. Obviously, the power supply won't put out 50 amps, but she will do 40 amp surge. So, that's our high current plugs, medium current, low current. We changed a lot of positioning, a lot of the components inside it. I added twin 68,000 microfarad caps, 24 volt 68,000 microfarad caps. So we moved that filter bank down there is the 24 volt filter bank. That's the high filters. And then over here, you can see in there, we got two 68,000 24 volt low side filters. These are on the 12 volt output side. So these are the 12 volt filters, and those are the 24 volt filters. We moved our logic board because the way this was screwed to brackets on this, and it kind of was like a sandwich type of deal, and mounted right down below down here. So we got away from all that, but she's working good. Get my meter here. Okay, as you can see, no output. The power's starting to come up. So, I can run 1 volt on this thing, all the way up. To 1448. I like the idea of that. I need to replace this meter because it's dug up. But that's just cosmetics. We can always replace the meter at any time. But I can dial the voltage right down to 12.5 volts. I can go to 13 volts. Which should be just about on the dot. And it's 13.5. So she's good to go. She's golden. 13.5. She's just a little bit low off center. And full bore is 1447. I'm ordering a high voltage protection circuit off of eBay. So if anything happens to the regulators, and like if they short and she passes 24 volts, they won't come out to the 12 volt side. So I can set the high voltage. So anything above 15 volts is what I'm going to set it at. Anything over 15 volts, she'll automatically trip off the power supply. So therefore, not destroying good radios like that over an analog power supply deciding to have a temper tantrum. That's the only thing that I fear about running analog power supplies is, these regulators. They have been known to go. And 90% of the analog power supplies, or linear power supplies, when those regulators go, they usually don't just open up, they short and throw 24 volts straight to your radio. Well, at that point in time, you've really caused some damage. So, the voltage protection board, it's only a $2 item off of eBay. You know, and I got plenty of places to mount it in here. It's just a little itty-bitty board. And it's relay controlled, so once the voltage reaches my set voltage, which will be 15 volts, it'll disconnect this rail back here on this board, which is the 12 volts out. So any equipment that is plugged into it at that point in time will be totally protected. I don't want to protect it from low voltage because I can utilize this for, as you've seen, 1.1 volt, 3.3, 5 volts, all the way up through to 14.4. So we don't want to undervolt protect it. But undervolt's not going to hurt anything. It's the overvolt we got to be very careful with for protecting the future of our radio equipment. Yes, you see the voltage going up because I'm turning it up. That's where I put my max. I added this control, and that right there, seeing that you can't get much information on this power supply online, this is your overall voltage output for the power supply. I removed the jumper they had there, and then I wired up, it's kind of hard to see it, but right there, this pot, over to this board, and then it's going to the back side of this resistor, so I can set my max voltage right here, and then I just vary from 0 to that max set voltage with this, which I like. This way, if I'm working on a radio, I can find out what it's doing. If you put it in the car with the engine off at 12.0 to 12.2, 12.4, and then also with it at 14.4 all the way up, we can also see what that same said radio would be doing with the engine running, which, 14.4, you should be able to get out of any vehicle with it running. So, all right, people, you take care. Have a fine one. We'll catch you later. But yes, this has been my latest project for the last 2 days. Catch you later. See you on Facebook. Hello, everybody. Well, we have our voltage protection board. So I can finish up with the power supply. We're going to use a traction control relay out of the old Prius that I had. And that's going to, turn all outputs on or off. We're going to remove this relay, take its signal off the bottom right here to control this relay. Basically, these wires here will be all cleared out, and we'll be able to mount the relay, which this pin right here will be soldered directly to the board here, all nice and neat. Hopefully we can get this board, once I get this relay off here, we'll mount it up in front up here, neat and out of the way. Should look alright. Then I can re-zip tie all these lines that I got just kind of floating around in here. It's still a work in progress. Power supply works, but it's just not safe yet until I use this. So there you go. Hopefully the next video we'll have this relay up in there. We'll have this control board in there. See ya. Hello everybody. Well, we got her done. Got our wires all put back in the loom. Or tied up, I mean. Added quite a few more. We got a 40 amp relay. It's a traction control relay out of a Toyota. We got our over voltage protection. That's what this relay does. Anything over what voltage I set will automatically cut all outputs of the power supply. So therefore, if the power supply wants to put out 24 volts, the power protection will just stop it. It won't be frying no friggin' radios. Up here, we got our little power protection board. Right here. There's a slight delay when you first power it up. Right now it still hasn't drained down from testing, but she's still doing about a little over 4 volts, even though it's turned off. That's just stored in the capacitors that I got, the output caps on it. But we'll turn it on. You're going to hear it turn on, and then in a few seconds later, this relay will click in once the power reads good, and then we'll have output. So here we go. There you go. 1441. And that's what we're reading down here, roughly. But there's a little better look at the control board. So, yeah. She works pretty good. I'm trying to get it turned around here. So we got our variable voltage, which I got it cut, so it cuts off the output at 14.47 or 14.7, I think it is. Yeah, 14.7 volts. So basically, we'll go up here, little at a time. You should hear it click when it gets there. There she goes. She just went into protect. As you see, the voltage will start to drop on the output. That light will start to dim down. That will stay up. And inside, we're still reading 14.6 something. Basically 14.7 volts. Pretty much that's it. And then once the voltage resumes back to a safe level, which is around 14.4, she kicks back on. So there we go. And it's quick response. It's not even a second. You know, it's like half a second. Where another voltage protection board I tried, this cheapo right here, that thing had like a 2.5 to 3 second delay on it. Well, in that amount of time, 24 volts would have already fried equipment, where this controller in here is instantaneous. You know, the second it sees that voltage go up above what I set, you know, it is programmable. There's 2 buttons on it here. I can set my low and my high voltage. But whatever my high voltage is set at, the second this sucker encounters that, she'll, as you can see, there's no red light on right there. The second that comes back down, 14.4, she'll kick back in. There she be. Then I can nudge it up just a little bit. But if I nudge it past that 14.7 mark, she just cuts back off. Which I like that. I like that a lot. Don't need to run more than 14.4 volts into any equipment. You run more than 14.4, you're just asking for trouble in the future. But my main reason for doing this is I do not like linear power supplies. You know, these old analog power supplies. Too many things can go wrong, too many regulators, and usually when these bad boys go, they short. You end up with 24 volts on the outputs. 24 volts in any radio is not a good thing. But there you go, people. That's the update on the power supply. I don't think it came out too bad. I need to clean it up a little bit yet. It was hard to get this soldered with, you know, just my cheap station there. You know, it could have came out worse, but it also could have come out better. It took a lot of heat to get these things on there. But we got her, and she's solid as a rock. So, catch y'all later. See you all in Facebook.